So, Gareth, if you're able to take it away.
Thanks for your patience, everyone. And cheers, Tom. So I'm the program director for the three physics programs we have here at the University of Hull. We've been quite highly rated for student satisfaction for a long time, and we've just recently updated our degrees to competence-based design. We're just about to roll out the second year of that to the students, and it's gone pretty well so far. But something I think I wanted to talk about today was why it's a little bit of a tough crowd sometimes. So there are two big reasons that students give for choosing to study physics, and one of those is that they want to sort of study the nature of reality and understand how the universe works on a fundamental level. And one of the other reasons they give is that they don't like writing essays, and that's not a joke. Neither of these, unfortunately, are motivations for them to develop things like communication skills, team working, or really anything to do with career development. And know that careers are not really commonly thought of in the specific by early stage physics students. So students commencing HE physics very much do not have a well-developed plans for their careers. And although I think that's probably fairly common in other subjects, there are a couple of exacerbating factors in physics. And one is that there's the large fraction of students choosing the subject for the subject and not for its career prospects, even if they're aware that there are lots of them. And the other is that there are lots of them, and that level of choice can be quite paralyzing. We also have the highest, I think, tied with mathematics, the highest instance of neurodivergence, and a lot of students have been trained in very black and white thinking from all subjects. I mean, there's a right answer, right, in physics. That's what everybody thinks. So if you're not thinking about employability until the third or fourth year, you're not really thinking about what you need to do to sell yourself to an employer, and what skills you're actually going to use. And the job market is quite sort of hostile and busy now. And if all you're thinking about early on is next week's assignment and how you're going to remember all the stuff for your exams, you've got a pretty sort of tough crowd who are going to defer thinking about employability. And so introducing competency has been sort of quite a tough sell in some ways. So to address this, I've done a few things. One is redesigning the physics degree around competencies, and then the focal point of those efforts has been a series of assessments running through the degree, which are entries in a reflective skill portfolio, which is perhaps not super original, but please remember I'm working with skeptics here. Actually, the Institute of Physics is sort of quite interested in this approach. It seems original in the discipline. So two of the competencies that we find the hardest to teach, develop and assess are professional conduct and ethical integrity and lifelong learning and careers. And the wording up there is what's expressed at level 6. We do have an integrated master's version, but I'll leave that out for time. The method that we're going to use to try and assess these is a self-reflective portfolio, and that's undertaken once per trimester for levels 4 to 6, and so it builds up over time. Students can see sort of what level of progress they've made throughout their studies. And students are asked to write a short reflective piece on 3 topics. Sometimes that has to be on a specific program competency so that we cover all of them. But each year they will have to reflect on the 2 competencies that I've got on the screen at the moment. Each entry is worth 5% of the module it's within, so that's not much, but hopefully a little bit of a sort of sweetener to try and engage with it. And if done adequately, students might expect a little less than half a grade boundary's worth of marks on a module. So engaging or not with this has made the difference between passing and failing in a few cases. That's particularly true amongst students who probably benefit the most from this kind of practice. One of the shortcomings of our graduating cohorts that we wanted to address was the lack of self-awareness of professional skills, even ones they had. And so introducing the program level competencies has made those skills explicit. But as I've tried to explain, our physics students may not be inclined to engage with those. So the kind of way of kind of wrapping this all up to say is that the missing element is this second competency here, lifelong learning and careers. But we want our students to reflect on strengths, their weaknesses and the goals. And we also want them to be aware of the skills they have how they are improving them over the years, and we want them to be able to articulate those to future employers. It's very important. So in this case, the reflective work itself is evidence of that capability. This is a truly authentic, effectively a summatively assessed self-appraisal, something they genuinely will have to do, which is sort of reasonably unusual amongst most of the assessments that we have in physics. Now, because our students are probably going to feel a bit lost when it comes to doing something like this, they've not really had to practice a lot of writing or reflection. I prepared for them an explanation of the benefits and the approaches they might take, and I've described the Rolfe and Driscoll formalism so that they have a process to follow, almost like an instruction manual, so they know what they're doing. And I've also signposted to other reflection methods for those that are interested. So separately, we've also got some examples in a kind of rubric, so examples of reflections, because some of our students prefer to see, like an actual example of what they're being expected to do. Marking-wise, we're using the Hattner-Smith reflection assessment model, although I have to say I've translated that a little bit for colleagues to mark, so that because they may be a little less immersed in pedagogical jargon, and also for the students because they might be a little bit lost by some of the terminology there. These portfolios, they'll be marked non-anonymously and in the first instance by their personal or pastoral supervisor, and I've second marked all of that sort of first year's work to calibrate the markers and check the feedback consistency, and generally speaking, that's gone pretty smoothly. There's been a few outliers, but that's always expected. One of the benefits here is that supervisors marking their own tutees, they get to see the contents and they can then use that for structuring their pastoral progress meetings, and they can compare that to any plans made in previous submissions. And that's really handy because the students are often turning up to their progress meetings with little or no prior consideration of what they might discuss about themselves and their aims for the next year. And also that means that any concerning submissions, sort of mental health disclosures in the portfolios, and we have had those are best read by the pastoral supervisors so that they can be addressed. So just to sum up, physics students are skeptics when it comes to professional skills development because they came to study physics. And what we've tried to do is explain that those are actually linked and facilitate their own self-awareness, a bit more of a developmental mindset, and we have them writing the self-reflective portfolio entries from sort of start of the degree right up to the very end, which is itself, we think, a very authentic professional practice for the kinds of careers they may go on to. And at the close, hopefully that gives them a document that they can use, almost like a sort of the basis of a personal statement when they reach the job market. Thank you very much.
Well, thank you very much, Gareth.
Thank you.
Much appreciated.